aspect ratio. Can you do Control Z?
India's Techade. The decade of technology is here. As one of the world's fastest growing economies, we are ready for a generational shift. A rapidly growing, digitally enabled, skilled workforce is fueling this accelerated growth. Digitization is transforming lives and businesses as we know them. Coming together to drive this deep tech digital skilling revolution with the Government of India and nasscom is FutureSkills Prime. Democratizing learning by offering students and professionals an unparalleled opportunity in skill development with nasscom certificate to give your career an edge. Government of India incentive program to fund your skilling ambitions. Customized course plans to craft your learning journey. Access to nasscom exclusive career support in the form of job fairs, hackathons, internships and skill challenges. Learner ledger to track your progress. Competency diagnostics test to evaluate your tech aptitude. Opportunity to explore new age tech as well as professional skills. There is something for everyone within the FutureSkills Prime's foundational, bridge and deep skilling learning programs. The FutureSkills Prime learners are taking center stage in emerging tech job roles across industry sectors, with 40% women learners working with colleges and universities to integrate tech skills with the National Credit Framework, aligning popular industry courses to National Skills Qualification Framework. Our learners have gained a competitive edge over their peers. Our strong partner network helps learners make the most of their time spent on the course. Our corporate partners go the extra mile to make FutureSkills Prime a success. Our government partners bring credibility and authority to the programs offered. Powered by the Ministry of Electronics and Information Technology, Government of India and nasscom, representing the $227 billion technology industry in India with the skilling support ecosystem. We aim to make India the digital talent hub of the world. Let's build the digital talent nation together.
Good morning, everybody. So welcome to our session today. Before we start, I would like to introduce you to the speakers. And of course, I hope all of you know we are going to be covering K nearest neighbor today. And for those of you who are joining this session may not know, we already did a precursor session on, which was on linear regression earlier. And MeitY was there along with Prashant earlier. Today we have Madhav as a speaker. So Madhav will be covering today's topic, and Madhav is a data scientist by profession and a product manager with Reliance. He worked earlier, and with he has an immense experience of data engineering and machine learning concepts. We also have Vineet who will be supporting us. Vineet has like 30 plus years of experience in leading engineering efforts in software across domains and telecom, digitization, media, etc. We also have Aishwarya, who is from Telstra here. Aishwarya manages the strategic relationship and the strategic operations at Telstra. I have my colleague Sangeeta along with me. So I'll pass it on to Madhav from here to talk about the topic a bit, and then perhaps start by another 2 minutes as people are joining. So over to you, Madhav.
Thank you, Anjana. Thank you very much. Thank you, nasscom and Telstra, for giving me this initiative to walk through along with K nearest neighbor. Good morning, everyone, ladies and gentlemen. It gives me an immense pleasure to introduce you to a versatile algorithm that we will be learning today, which is also known as K nearest neighbors, and also apparently very famous with KNN. So let's deep dive in detail and understand how does this algorithm give valuable insights from the data and make us learn a lot of things. So I'll quickly share my screen. Please let me know if it is visible to everyone.
Visible. have to just make it full screen.
Can we see it full screen mode?
Yes.
Perfect. Great. So in a very short one-liner, if I define k nearest neighbor, we can say nearest is dearest, and the prediction that we guess is the clearest. That is what KNN defines. Moving on, we'll walk through on the topic contains that will have introduction to KNN. We will also talk on example of KNN, and then we'll also see what is the need of KNN and how does the algorithm work. We'll see step by step in each and every step that we run like a pseudo code. Then we will walk through on the pros and cons, and then we'll see what are the applications that are using KNN to admit all the walks of life. And then in detail, we'll see step-by-step explanation of Python libraries, like what all libraries do we use to accomplish this task in model building. And followed by that, we'll also see how the evaluation is done. And at the last, we'll have a hands-on session on a small data set that we have, and we'll see how the insights and the accuracy is generated. So if you see KNN, as it says, it's a non-parametric supervised learning technique. When I say supervised learning technique, it means it has already labeled. We know what is the end target that needs to be achieved. And we try to classify those data points into a given category, which is helped by using the training set. So we divide the actual data into two steps, training and test. So we put all the training data into the algorithm from which it learns, and then it gives result on the test data where we evaluate. So in simple words, we say it captures all the information of the training cases and then classifies it being based on the similarity. So if I say there are two properties, very essential properties that KNN follows. First is known as lazy learning algorithm. The reason I say lazy learning because it does not has any training phase, any specialized, is it just wants all the data that is used for classification. And the second property is non-parametric learning. Now, when I say non-parametric, it says that it does not have any assumption about the underlying data, which clearly means that it doesn't follow any function, rather it works more on similarities. So if you see the example over here, say suppose we have an image of a creature that looks similar to a cat and a dog, but we want to know either whether it is perfectly a cat or a dog, that identification should be done. So in this case, the KNN algorithm helps us and it works based on the similarity measure that is connected. So if we say our KNN model will find similar features that are there into the image, and based on that, it will try to find what are the similar features that lies either on the cats category or the dog category. So if you see over here, I have an input value that looks similarly like cat. I have a KNN classifier model that is trained on both features, cat and dog. And finally, the predicted output, it classifies it as a cat. So based on this, we come across understanding what is the need of KNN. So suppose if we see, we have two categories over here in the picture. One is category A and category B. And suppose there's a new data point that comes into the arena and tries to find its place either on the other sides of both. So we see the similarity. We try to identify the similarity based on the K value, which is using a Euclidean distance formula or any Manhattan distance formula. Based on those similarity, we try to categorize the new data and get aligned. So if you see before KNN, we can see this blue dot, which is a new data point. And then after KNN model is performed, it tries to find the nearby category points which are similar to it, and it gets assigned. So over here, the new data is now assigned to category A. Then we'll see what is the walkthrough of the code. So there are total 6 steps which defines the working of the algorithm, which starts with selecting the number k of the neighbors. So there are multiple steps or multiple techniques, you can say, to decide the value of k. After we decide the value of k, we try to calculate it with a distance formula. In this case, I've just mentioned Euclidean distance for the k nearest neighbors. And then we take the k nearest neighbors as per the calculated Euclidean distance. Once that value we receive, we then try to put it, and based on the count of data points in each category, we try to segment it. After that is done, we try to assign a new data point to that category for which the number of the neighbors is maximum. Suppose if I am taking k value as 3, and I see the nearest point on either sides. Like for example, I have a red category and blue category. If my K3 has two red categories and one blue category, so my data, new data will be now assigned to red category, and hence the model is ready. So we keep iterating this for all the new data. So from step 2 to step 5, the whole algorithm works. And based on this pseudocode algorithm, we now try to understand each and every step which helps in working the algorithm to make it success. So if we see the step 1, we try to collect and pre-process the data. So basically we gathered the label data set. Now when I say label data set, it is a supervised machine learning algorithm. So it contains instances with known classes. So basically we know the end target that we have to achieve for the problem statement. After the data is collected, we then pre-process the data by cleaning it. We see whether there are any missing values. So we need to handle the missing values. We normalize or standardize the feature that is required. Once this pre-processing is done, the data is well maintained, ready, and then ready to push into the algorithm. Before we push into algorithm, step 2 arises, which tells us to choose the value of k. Now choosing the value of k determines the number of nearest neighbors that we have to consider for the new point that is coming. So we denote that nearest neighbor as value k, and that will be considered for either classification problem or regression problem. Now let me make one thing clear: classification works on discrete aspects and regression works on continuous aspects. So the value of k typically chooses beforehand, which we have to choose because that can affect the performance of our algorithm. Now the main task over here, which is again a challenging, how do we get to know the value of k? So basically the value of k determines how many nearest neighbors are considered when we are trying to make a prediction over a new data point. So the main challenge comes is if the k value is small, the model may be sensitive to the noise. So if we are taking a smaller value of k, we may be prone that the model can be can make itself more prone towards the noise. And if we
Yeah,
take a large value of k, the model might lose the local pattern that is working in out. So there are
yeah,
some
Madhav.
methods that usually,
So,
yes, sir.
sorry, Madhav. I want to intervene. There's a question. If you can take it on the probably a couple of slides back. How to assume points x-axis and y-axis in graph?
Okay,
I'll speak through those questions just to help you.
yeah, sure. So
If you
the
stick to
answer
the
to this is in my, yeah. So answer is the answer to this would be in my slide where I have the Euclidean distance. So based on that, I'll answer the question. So if we
okay,
see this, the methods for way, the first is cross validation. So basically it tries to split the data set over here, and then the data set that is split, it makes sure that each value sometimes acts as a training set or sometimes acts as data set. So if we choose the value of k, the best value of k is based on the performance that is giving, in which we see which is the highest accuracy, what is the f1 score, and what is the relevant metrics that we use for the validation set. So cross validation helps. Along with that, we have an elbow method which tries to plot the performance, which is the accuracy against the values of k. So we decide a starting point of k and an end point of the k, and we drive it to the values that we have. And based on the trade-off that we come between the bias and variance, we get an instance. So for example, if you see in the diagram, we have an inflection point at 4 on the x-axis. So based on that, we say that the elbow bend, the maximum elbow bend is finishing at value 4, and then after that the value is slightly differing. So the best optimal solution for the k value will be coming on number 4. So in this case, I would say that the cluster of k value will be taken as 4 in this case. After elbow method, if we are not sure about all the above two methods, we can also take odd values for binary classification, because it makes ensure that there is no tie between, for an instance, if I select value k as 4, if it tries to take two value from red and two value from the blue category, there can be chances that both may end up giving a tie. So in that case, we always bang on, or we try to use odd values for our classification, so that none of the tie occurs in the instance. And then again, if we are short with all the three methods, the best method is to go with the domain knowledge, because a person, we also call this as SME, which is subject matter experts. They sometimes help and provide insights which help us to take the proper insight and the proper value of k, which is in a appropriate range. So these are the 4 methods that help us to follow and choose the value of k. Once the value is being suggested, we then try to compute the distance formula, and that brings us to the question that was being asked. So for an instance, we try to compute the distance between the input instance and all the instance in the data set. The distance matrix uses Euclidean and Manhattan. We also have cosine similarity used, but primarily we use Euclidean distance for the data sets which are fairly distributed, and Manhattan for the rest. So suppose you have 2 points over here, say A is, which is my input x1, y1, and B as x2, y2. So we try to take the square root of the sum of squared differences between x2 minus x1. We sum it with y2 minus y1. So if you see the diagram here, we plot the instance A and B, both the points, and based on the x1 and y1, y2 and y1, we try to calculate using Euclidean. So the x coordinates and y coordinates gives the total difference, and then the total difference has been sum up, and we take the square root for the same. Followed by, we also work with Manhattan distance. So in Manhattan distance, we have a kind of protocol that has been followed. So if you see over here, the declaration for the same x2 minus x1 summation with y2 minus y1 is given with a b. So for example, I have to move from one distance to another. I need to follow a protocol which is given as AB is equal to AC plus BC. Okay. And that will define x2 minus x1 as AC, and BC is y2 minus y1. So in short, if I give it in a real world example, Euclidean distance is taking flight from one position to other position. And then if you want to use another mode, we have to take either a railway which is bound, or a roadway which is bound towards the roads that are developed. So
Other,
that
but
helps
you've
us.
used different kind of brackets in both the formula on the right hand side and left
Yes,
hand side.
yes, yes,
So here you
yes.
put the
So Manhattan uses absolute difference, which is mentioned. So they try to bring the absolute difference of the first part, which is AC, which is x2 minus x1, and BC, which is y2 minus y2 over here. So if you can see over here, I've mentioned both, and it takes the absolute difference, which is given by the sign. And once we get with the distance formula, we then move it to k nearest neighbors, which is the actual algorithm. So once we are done with the k instance, with the shortest distance, whatever the shortest distance we have in the input, we try to consider that as the nearest neighbor. And once the value has been input, the algorithm tries to classify based on the data that we provide as an input. So initially we try to classify or do regression. For classification, we try to determine what are the majority class labels amongst the nearest neighbors that have been assigned to the input. And for regression, we just try to compute the average or the weighted average for the target variables of the k nearest neighbor, and then we assign the instance based on that. So it typically depends on the use case that we try to take. For classification, we just take the majority of the k neighbors that we are assigned based on the k value, and for regression, we just take the weighted average, and then we come up with an evaluation, try to see what is the error gap between them to make it more redundant. Once this is done, we then output the result. So we return the predicted class label for classification, and then we predict the value, giving it into a in continuous format as an output of an algorithm for regression problems. So to sum up everything, all this steps, which we have total 6 steps, I have a GIF diagram that would help you. So for example, if the value is K3, we see the green is 2, the red is 2, it makes tie. When we have 5, the green is here. So if you can see K1, it is giving me answer as prediction as green. So if you see, the moment we are increasing the value of K, the number of prediction on green and red have been increased, and based on that, the prediction is given. Yeah, see K5, we have 2 greens and rest of the red. So the prediction will come as green. And once we see K4, there's a tie coming. It's a tie over here on the prediction side, and it will not make the perfect output. So this is how the whole KNN example works. Do we have any questions over here?
Yeah.
Okay,
Any questions so
perfect.
far? The basics are covered. I don't see anything on the
I hope everybody is
chat or
able to
chat.
follow through, because I don't know if you did attend our previous session on regression, linear regression and multiple regression. And, this is a continuation of it. It may sound a little more, detailed.
Okay,
How
so
much?
to give a one-liner glimpse on classification and regression, so for an instance, if I want to predict whether what is the price of the share market that would come ahead, I will use a prediction problem wherein I have to predict the value exact. And if I want to do a classification problem, I need to classify whether a current person will attend the lecture or will attend the session or not, based on multiple values that have been input. So this is how the whole regression and classification problem has been divided across. And when we come to KNN algorithm, it is open for both the ends. If you want to perform classification, we need to work with the K value. And if we want to perform regression, we have to see the majority vote on average and weighted average. Yeah. Okay. So moving on, we see pros and cons of KNN. So basically, we see, let's first try it on the pros. So it is a very simple algorithm. We try to understand and interpret, because again, first step, we just need to clean the data. Second, we need to identify the K value using all the methods. Once the K value is there, we need to calculate it using the distance formula. Primarily, we use Euclidean or Manhattan. Third one, which we use is cosine similarity. Apart from that, whatever the K value is arising, we try to see the nearest neighbors, and based on that, the prediction is done. So it's very easy and easy to understand and interpret. It is very useful for nonlinear data because there is no assumption. As I said, it's a lazy learning program, and it has no, it is a non-parametric, so it won't take any assumption of the data. Rather than, it will take all the data, and based on the data presence, it will make its decision. It is a versatile algorithm, as we can use it for classification as well as regression. But again, it can be time consuming based on the inputs that we provide. So it's highly relative to high accuracy, but there are much more better algorithms that supervised machine learning model uses. One to overcome on KNN is random forest algorithm. The cons that we use it's computationally bit expensive algorithm because it stores all the training data. So we make sure that the all dating training data is fetched into, if a new data point comes in, we try to calculate the K value again, and based on that, the whole process works. It requires high memory storage because, again, in the above point, we say we store all the data points, and based on that, the storage is compared. Other than the all supervised learning, the prediction is quite slow if we try to optimize in case of big O notation or big N notation. So the prediction is quite slow in this, because again, we have to store all the training data. A new point arrives, we have to perform the whole process, and then we get the value. So prediction is slow, and it is very sensitive to the scale of data as well as the relevant features. So we make sure that if we have not handled any negative value on the fly which comes as an input, it can affect the model, and the model will not perform properly. So these are the
Arthav, we
pros and
have
cons.
two questions, sorry to interrupt, which
Yes,
are,
sure.
one was, somebody said that, could you explain what is showing in green and red in that circle that you had, where you were showing
Yeah,
here? Could you explain
yeah.
this?
So yeah. Yeah, so basically the green one is the category, one category which is aligned with green, and another category is aligned with red. So the moment I try to increase the K value, my the number of nearest neighbors that is taking will be affected. So for example, K2, K3, we have one red coming in the circle, and it moves ahead. Yeah. So the moment the K value increases, the prediction increases. In whichever category the count is more, that is taken ahead as a majority vote, and the prediction will show that category. So for K1 only one, so green. K2 we have two
You
greens,
are
it will show
talking
green.
about a new point, right? You're talking about a
Yes,
new figure. That's what
new
I think
point.
people are confused. You're talking about a new
Yeah,
information that has come. How will that information be predicted, whether it is closer to green or whether it is closer to
exactly.
red?
Yeah, yeah. So for the instance, white is the new data point that is coming in my red category, in between red and green category, and based on this, placement, which is particular on the x-axis and y-axis, we then see the k value, which is nothing but the nearest neighbors, and then that will take the whole circle increase. The moment we increase the circles, the prediction increases over here. How many the nearest neighbors that are coming, that will be calculated, and based on the majority vote that we take, since we are trying to classify it into red and green, the majority vote will be taken, and the prediction based on that will be given either on the green or the red side.
The second question is, how accurate is KNN method, the accuracy of this model?
Okay, accuracy of this model defines on the use case that you're using. So in those cases where you want to find similarity based on distance, in that case KNN would be an ideal, because the nature of the algorithm works on the similarity features. So wherever we use the algorithm, which the outcome that we are searching should be based on similarity, KNN will perform very well over there, because again it is totally bound towards the k value that we use, followed by the distance formula that we will use in the algorithm. So it's bound towards the similarity feature. More the similarity, more the perfect the algorithm works. Any more questions?
Yeah, there are a couple of questions. I don't, maybe you will address, I believe you will address, like what is, what are the use cases of KNN in the real life problems where they are
Yeah.
applicable?
Yeah,
And
so I will cover that in applications. I have quoted with some real world scenarios that we are using right now in our mobile phones and daily routine. So I have mentioned that in my upcoming slide.
what is the difference
Which
between
brings,
classification and regression of KNN? That's the
okay, so in short, I can say that the classification, if you want to perform any binary values or multi classification, in that case, you want to only tell which category it defines, which would be a discrete value, that is classification. And if I want to get some value generated out of the input, and the final target value should be a numerical value, or a value that should impact, in that case we have to do regression. So both has its own differences. One will work with the exact value that you want, and one will work on the category in which it has been classified. Yeah. So applications that we will be using is Google Maps. So basically, KNN applies, like Google Map applies KNN for finding nearby locations. So if you're searching any restaurants, gas stations, or landmarks, KNN is the one doing this for you in the backend. For Uber, if you want to try, it utilizes KNN for real-time location-based ride recommendations. So for example, any riders nearby your location, it will try to map it, and the confirmation will be done to that particular ride for yourself. And then in Airbnb, we use KNN, that is used for recommending similar properties that we use based on the history and the preferences, or the search history that we do. So they try to optimize their algorithm using KNN. So that particular module uses KNN based on the search history and the preferences, and then they optimize it. So here are the three applications that we use: Google Maps, Uber, and Airbnb. So yeah, any question, Anjana?
no, only so much for now.
Okay, perfect. So this is a part which is really very tedious. So we try to understand it step by step. I have put the code snippets also, which will help us that which particular algorithm or which particular um, library we use and what are being called. So for example, step one, we import libraries, which is being by importing necessary libraries like pandas and scikit-learn, numpy, we try to import. So we use numpy, we use scikit-learn, which is sklearn, we use neighbors package, which imports the k neighbors classifier. Then we use sklearn. Under that, we have model selection that is used to import train and test split. So basically, it helps us to divide the data into training and testing. And then we try to pre-process, in which we try to normalize the data using standard scalar. That's where we input the necessary libraries. We load the data set using pandas. So we have an inbuilt data set called iris data set that we will be using in the hands-on session. And then it contains different measurements of different flowers, which is segregated across three categories. Now once we split the data over here, we try to split x and y to the target and the input, where x identify itself as the input and y is my output. So if you see over here, that x and y is now divided into four parameters, which is x train, x test, y train, y test. And then I use train underscore test underscore split functionality, in which I pass my input that goes in x and my output that goes as y as a label data set. And I now define the test size. So for example, test underscore size is 0.2, which says that 20% of my data goes in testing and the rest 80% goes on the training side. So over here, X train and Y train will hold 80% of my data, and X test and Y test will hold the 20% of the whole data set that we have. So once we split the data, we now choose the value of k. So while choosing the value of k, we have seen multiple methods like cross validation, domain knowledge, elbow method, and one more which we saw is odd values. So for an example, we have just considered k as 3. There's one more method that I will show in my hands-on, which is the grid search CV, which automatically I will assign the range and automatically it will decide the best value of the k based on its instance and distance, and then it will automatically assign it to the algorithm. So we'll see in the hands-on session. The in fourth step, we try to normalize the data. So basically, for normalizing the data, there are many various techniques, which includes min-max scaling and standardization. So we use a very basic one, which is standard scaler. We try to fit that on our X train, and also transform the fit that is done on the X train will now be transformed on the X test. So we try to train it both X train also and X test also, so that my data that is going inside the model is optimized and normalized. So once we normalize the data, then have the training model coming in picture. We then create an instance called as KNN, and k neighbors classifier is being injected, or we can say the algorithm is called, and then we have n neighbors as the parameter that will take the k value. So for example, if I'm taking k value as 3 for an instance, the k will be assigned over here, and based on the value of k, the KNN algorithm will be then fitted on the training data, which complies of X train and Y train. So the four parameters which we have: X train, X test, Y train, and Y test, all the training data will be taken into fit, in which holds X train and Y train, and then the model will be trained. Once the model is trained, we then try to make a prediction. Now the prediction, it seems that whatever model we have trained, whether my model is able to predict some values or not, or predict some category or not. So in that case, we then try to test the model, and we try to predict the model on X test, which is again lying on the test side. So for that, we use ypred. We give the model name KNN, and we then show it X test, and then try to see the value of ypred on the fly. Once that is done, we then determine the class label based on which the class is assigned on the test data. And then we see what are the majority class amongst the k neighbors. Based on that, the instance belonging to that class will be assigned. So we determine the class labels, and then once we are determining, we need to check. We need to check the model's accuracy. So in general, we can use accuracy as a metric. We also have precision, recall, and F1 score, which we use to assess the model's effectiveness and how accurate the model is. So we try to test again it. So basically, for training the model, we have used X train, Y train. The whole training data set has gone. To see whether my model is predicting properly or not, we are using X test. The last remaining component amongst the four is Y test. So what we do is we now place my Y prediction along with my Y test, which is the actual data which my model has not seen. And based on those things, we try to get the accuracy. Or if you want to take precision or recall, depends on that. And the whole process we try to keep adjusting the k value based on the accuracy that we receive. So if the model's performance is not satisfactory, you can then experiment with the different values of k. Remember, we can again, if you are dealing with a specific problem, we can again take odd values as the best metric, or we let the algorithm decide it using grid search CV. So we repeat this 6 to 9 step until the desired result is derived. Once the desired result comes into picture, we then give out the performance, and the model is evaluated, and then it is pushed to the production. So since we need to evaluate, there are multiple evaluation parameters that we have amongst the whole. So one parameter is, we see confusion matrix. So basically it divides itself into two by two matrix, which is true positives, true negatives, false positive, and false negative. So when I talk about true positive, we say that the predicted one is true, and in reality also it was true, so that falls under true positive. uh, the predicted ones is false by the model, and the reality is also false, so that will come under true negative. Then we have false positive, which is denoted by FP. In this case, the predicted thing is true, and and in reality that is false, so that denotes FP. Again, this is called as type 1 error. Then we have false negative, which is again denoted as Fn, in which predicted case is false, and in reality that is true. So let's take an example small to understand this. That will put more clarity on confusion matrix, since the name itself has confusion in it. So if I say true positive, so true positive is, for an instance, a person is having a disease, and the model predicts the disease to that person, that the person is holding that disease. In that case, it is called as true positive. In true negative, the person is not having disease, and the model also predicts that the person is not having disease, so that is called as true negative. In the case of false positive, we say that the model is telling that the person is having the disease, but in reality the person is not showing any symptoms. So in that case, we have false positive coming into picture. And then at the last case, we have false negative, in which the model says that the person is not having any disease, but in reality the person has the disease. So out of the four, false positive is type 1, because the model says that the person is having the particular disease, but in reality he is not having. So that is still a very normal case, because your life is not disarranged over here. You are still safe, because the model is making mistake over here, but in reality you're not having. But in false negative, this is a type 2 error, where that is very dangerous for us, because if the predicted model is saying that you don't have the disease, but in reality the truth lies that you have the disease. So in that case, you won't be provided with any treatment, and that can affect your health. So in this case, the confusion matrix lies. We have this 4 by 4 matrix given on actual values, which is the actual scenario, and the predicted values which the model gives us. Followed by that, we have accuracy. Now accuracy is again calculated using the value of TP, which is true positive summation summed with true negatives, the total value, and then we divide the total of Tn, Fp, Fn, and Tp. So we'll take the values of all four, but we will divide it with the true positives and true negatives. That is called the accuracy, because in this case we get the right values. So that is highly efficient. Wherever we have a balanced data set, accuracy plays a vital role. Apart from that, we also have other parameters, which is precision. So precision again comes with predicted yes. That means wherever we have yes once, that will be taken, and only the TP value will be taken, which means true, predicted true, and the reality is also true over here. And afterwards, once we get the precision is more towards wherever we are trying to be more accurate, more precise. In that case, precision value plays a vital role. Then we have recall or sensitivity, which again works on true positive ratio. So again we have TP and the actual yes. So there's a difference between recall and precision. Precision only takes the yes that is predicted by the model, whereas recall and sensitivity is working on the actual yeses, like the person who is actually having that data is being shown to the data of true positive, which the which means the predicted is also true and the actual is also true. So based on that, the value that comes will be taking as recall or sensitive. Then at the last, if we are not getting good values from accuracy, precision, or recall, or we are not trying to make any good insights, we then go to F1 score, which is again harmonic mean, which takes precision and recall. So basically, it is twice the precision recall in like we multiply the precision recall and divide it by the summation of precision and recall, and based on that we get the values. So all the calculations on Python will be done by a package called as matrix. Under matrix, we have accuracy score, we have classification report. So we just have to pass a function called as classification report. That classification report will automatically generate all the values that we are seeing over here. It will create confusion matrix also for us with the current values that are predicted right and the wrong ones on the true and false part. It will generate accuracy also, it will generate recall, precision, and F1 score, everything. So that we will see in our
So,
hands-on
Madhav,
session.
before we go hands-on, just couple of questions
Yeah,
here.
yeah,
So one is, what is fit, transform, and transform?
yeah. So fit transform basically says that whatever the model is learning, it tries to fit the data on training and testing, whereas the transform will start transforming the scenario. So for example, I want to in general case, we have data that is aligning on large scale. So there are some values that are coming 10, then there are values that are highly like it's 10,000, 20,000. So we need to bring it to a small duration. So in that case, it will train on X-train, it will try to fit the data, and then it will transform it into a smaller scale, which will get aligned into 0 and 1. So all the values will be submerged and it will bring it from 0 to 1. Between that it will lie. So in that case, fit and transform comes into picture. Whereas in X test, we just transform the data and bring it to the actual ratio.
Yeah, I'll just add to that. The reason we actually bring them into standard range is it takes lesser time for the model to converge. Okay, if the numbers are ranging in every possible number range, then the learning becomes time consuming. You will see that this is being done in every learning model that you will learn through in this session, in this series. This is one of the important part of the pre-processing.
The next one is, I think KNN is based on ML, and how is it different from CNN?
Okay, so CNN basically works on image data, video data. We try to convert the image data into an array. So you try to take the pixel values of the image, convert it into a array, and then we try to process it. And it basically takes the deep learning approach, wherein we try to create a network, shallow network, deep network, on architectures, and then it is taken ahead. So because it has flatten, we try to flatten it. We try to use sliding windows in that. We use padding that helps us to
Yeah.
identify it more clearly.
I'll try to simplify this a little bit. These two are very different. Whoever has asked the question, uh, KNN, as Madhav has explained it very deeply, it's about searching in your neighborhood, figuring out which person dominates, and you start identifying yourself as a data point to that type, right? In CNN, it's convolutional neural network. It's a pattern that has been taken from a science, physics. So the idea is not at all related to with this. There the NN stands for neural network. Here it is nearest neighbors, right? So that piece are unrelated, but still for your benefit. CNN helps you to sample the larger space into a smaller space and try to do an averaging of that space to form a new space. For example, you have got, let's say, 600 by 600 worth of image or data points, right? You first of all make that linear. So how much it becomes? 36 two zeros, two zeros, which basically become 360,000, right? This and these actually become the input parameters to any model. This is humongous, right? This is a very large set of input parameters through which the model has to learn, and that is not okay. So what you do is you try to optimize it by compressing this whole range into a smaller one by projecting and doing certain other methods which Madhav just mentioned. bring it to, let's say, 50 parameters, and then you go through the rest of the learning process, right? I'll going further deep would probably confuse you more, but largely they are very different domains. Okay.
Sure. And how do we validate data for KNN classification?
We validate using evaluation metrics like confusion metrics, and accuracy precision depends on the use case that we use.
If the data set contains some character, what we should do to remove it?
So basically, the first process in pre-processing, if the data is not proper, we do feature selection, in which we try to remove those features which are having character. So machine only understands binary languages, which is zeros and ones and numerical language. So we try to convert even the categorical data. So suppose if I have a column that is having green, red, I need to do one hot encoding to it, converting green as 0 and red as 1. Or if we have more, we use label encoder. So that will automatically detect 1, it will assign 0. The next new one which is coming, it will assign 1, 2, and like this it goes on.
Sure.
I'll
What is
sorry,
the,
I'll add
yeah,
I'll add a little bit more. This is very technical what Madhav said. I'll bring it little simpler. So let's say red, green, black, and continuing with the example that Madhav said. So so machine understands only numerical values, and numerical means they have to be in a ordinal manner. Like one is greater than zero, two is greater than one. Even if you are putting numbers and they do not have that kind of connotation, learning will not take place. I hope that you get it. Okay, but let's say you have put the values as a categories red, green, blue, right? So this is doesn't have any particular order. Machine learning, and this might be important for your final outcome. You cannot eliminate this column also, right? So what do you have to do? You have to create three columns, actually two columns. One would be red, another would be blue, and third would, you will say, if both of the values are zero, then obviously it implies the third one. So basically what you are doing is a column, a feature which was having red, green, and blue values. You have converted that into two values. Three categories converted into two columns having values 0 and 1. And 0 and 1 are ordinal in nature, right? And that way machine learning now, instead of having, let's say initially it was having, let's say three parameters, one of them was categorical, which has got three possible values. Now 5 would turn into 7 because two new parameters would get added which are of binary nature. Okay, this is what is called one hot encoding, which Madhav said. I just expanded on what Madhav said. Yeah, this is generally being followed in almost everything that you try to learn in your modeling.
Right, sir. Yeah.
what is the range
So I
of
can see
F1 score?
it's still 1,
Oh,
maximum
Yeah.
1.
okay.
Yep.
And how KNN differs from K-mean algorithm?
Uh, K-mean is used for unsupervised. So if your data set is not having label and target, so you have to use KNN. If you are working on unsupervised, wherein you don't have any end target, you need to identify patterns from your data. In that case, K-means helps. So ideally it does clustering, and here we try to see from the neighbors. So that's the difference.
And how KNN model perform regression?
It performs regression the same way. The only the input that we use is different. It uses average or weighted average in its final prediction. So based on the error that we get between actual and predicted, we try to get the weighted average. Based on that, the model takes the prediction.
Okay, and there are two similar questions. One is that how to adjust the K value? Can we randomly choose any value? And I mean, there's another question which is in line only, that what is the best way to determine ideal K value? Do we manually use or by grid method? How do we choose the K value?
Okay, so as I said, K value can be used using cross validation, wherein you make sure each data point acts as a test and train. Second, we use the elbow method if you're using that, and if you're not interested in using above that, we can also use the odd number format, odd classification. That is again a trial and error. You use 3, 5, 7, 9 like that from one range to another. Apart from that, let the algorithm do the thing for you. We can use grid search CV, which I will be showing you in the hands-on session, which we will learn. So I'll give a two range, starting range and end range. Between that, we can take the values, and automatically the k will take. So it totally depends on you. You want to do a trial and error method, you can do. You can take the valid method. Both methods can be available.
Sure. Thank you, Madhav. That answers a lot of questions. I think we can go to hands-on. And
Yeah. So
if
I've
people have any questions in hands-on, I think wait, for him to complete one step, and then he's put the link
so
in
I
the chat.
yeah.
Madhav has put a link.
So
Click on it.
yeah. So once you access this link, you will get the IPython notebook of KNN that has the all code line by line, which I'll be explaining. So I'll go through the screen. Yeah. So this is the one which will be loaded once you try to connect. So this is the interface of Google Colab. I need to connect the Google Colab, which will be again done. If you see the file section over here, just click the file section. Automatically the engine of Python 3 Google backend starts, which will connect me with the Python environment, and will help us import all the libraries. Since this section is more towards adding, if you want to add any data, CSV file or something from any folder, we can add it over here. Or else we have inbuilt sample data also, which is given by default by the Google Colab. So we are loading data from an inbuilt uh, uh, library, so we don't require this section. So if you see over here on the coding section, let me make it more uh, uh, zoom it. So I will be using NumPy. So import NumPy as NP. I'm creating an alias for NumPy library so that I don't need to use it the whole word again. I use pandas as PD. Now NumPy is used for numerical programming. If I want to do some calculations on matrix level or multiple calculations, NumPy helps me with that. I want to work on data frames, so pandas plays a vital role to convert my CSV file into a data frame. Then we have scikit-learn dot dataset, which holds all the dataset, and from that I'm trying to import load underscore iris dataset. This is the dataset which we will be using for building the KNN model. After that, we have scikit-learn model selection, which will help me to split my train tests into training data and test data, which will be done with the function using train underscore test underscore split. And then I also import the grid search CV, which helps me to define the best k value based on the parameters, which we will be looking ahead. Then I have under neighbors function, we'll import k nearest neighbors, which is k neighbors classifier. Since we are trying to do a classification problem, we have the same. And then after that, we will use pre-processing. From pre-processing, I'm trying to import standard scalar, which will normalize my data, and matrix, which we will be calling is accuracy score. So we will try to deal with accuracy score. Based on accuracy score, we will make the outcome. So there are two ways to run this cell. Either you can click on this run button, which will run the cell, or either you can click shift enter. Automatically the cell will run, and the sign text sign shows that the cell is successfully run with zero errors. The moment we move ahead, we now need to load the iris dataset. That is done again. So I create an instance called as iris, and then I'll call the function load iris, which will load the data. Now iris data consists of multiple segments. One is data, which will have the numerical one, and target, which will have my target values. So both iris data will be assigned to x component or x variable that I have created, and y is the target, which will have iris.target data. The moment I assign both x and y, I will then load it. It will hold value over here. So if for an instance, if you want, I can just print x. So if I print x over here, it will have all the numerical values that are having shared across all the four columns. And then on the same verge, if I want to print y, this will have all the categorical data. So we have 0, 1, and 2, which means we have three categories aligned over here. The moment we load it, we then need to check the shape of the data set. So x dot shape will show me what is the total rows and columns that are coming. and y dot shape will show the rows and columns that are in y. The moment I run, it will show me. So basically we have 150 data points right now spread across 4 different uh, columns. So 150 is the row, 4 is the column. And for y shape, which is the target, we just have one column which is having 150 rows. So this is where we take the shape. The next step here is to normalize the data using standard scalar. So I create an instance called scalar, or a variable that calls the functionality standard scalar. Under that, I will again assign, I'll again use X, and I'll try to fit that X using scalar, which will call the standard scalar function. Apart from that, we have fit underscore transform, and I will assign X to it. So basically what will happen is the X value that is there come, will use the standard scalar formula and the functionality, and it will fit and then transform my X value and normalize the data into a specific range. Once that is done, my now input data is all set to be inserted or to be ingested into the model to create insight of a learning. So the next step will be splitting the data set into training and testing. In here, we again, as I said, we create 4 different parameters, that is using the splitting of X and Y, input and output. So we have X train, X test, Y train, Y test, which is spread across using train test split. And we are giving the X normalized variable along with Y, which is my target. And I have mentioned test size as 0.2. So this indicates that 80% of my data is now towards training and 20% of my data is towards testing. The moment I run this, it will get splitted into 4 different variables that we will use for model building. Now we try to create a next step, we try to create a KNN classifier. So we define KNN and we call K neighbors classifier for the classification. So my model will be using KNN, but before that we will try to identify the important thing, which is getting the value of K. So in this case, what I'll do is I'll try to define the hyperparameter grid using grid search. So I will define a variable parameter grid. I will see what is my n neighbor, and the n neighbors will be given from a range 1 to 10. So basically I'm taking all the instances from 1 to 9 from the Python, which will take k values from 1 to 9. And then I'm assigning weights, which is again based on uniform or distance. So basically on these 2 parameters, it will try to decide which value it is taking, and the algorithm of grid search CV will itself tell me that it has selected a value, say one number, and on which weight function it has selected. So we will perform that moving. Okay, so we'll run this so that my parameter grid is initialized. And once the parameter grid is initialized, I will then use grid search CV with cross validation. If you remember, we had used cross validation in the PPT slide, which was the first way. So I'll recall grid search as a new parameter in which I'll pass the function, the algorithm of grid search CV with parameters KNN. Now this KNN is coming from the classifier KNN that has been created, which holds K nearest classifier. KNN is being brought here. We have param grid, which is again having n neighbors and weights to perform from range 1 to 10, which will actually work from 1 to 9. And then I will use cross validation as 5. So this will create 5 cross validations across the whole data set, and based on that the model will be fit. So I will use grid search CV, I'll fit. And remember, once we are fitting the model in any algorithm in machine learning, whenever we are trying to fit the model, only training data will be used. So we will use all of the training data, which is X train and Y train. So I'll ingest my training data in grid search CV to let it decide the best value of K and the optimal hyperparameter that it selects. So to get the best value of K, we will use grid search dot best underscore params underscore the value that we have passed in param grid, which is in our case n underscore neighbors. And based on what weights it is deciding the parameter, we use grid search CV dot best param, and based on that weights will be given. So we pass both the values that are added in param over here, and we will print what is the best value of k with the variable best underscore k coming from here, and best weight function using best underscore weights. The moment we run this, so in case the last time when I run it was having, okay, param grid has an error. Okay, knn is not defined. We need to load
No, you have not run. You
kn.
have not run that cell.
One
Don't
of
worry.
the, yeah, you've not run
Yeah,
one of them.
Yeah,
yeah,
you have
yeah.
not run that
knn
cell.
is not defined. Yeah, yeah, yeah. knn
Go ahead.
classifier. This is here.
Mm.
Yeah. So if you see now, the best value over here is coming k, and this is selected based on the distance that is coming over here. The moment we train, we now have value of my k printed in best underscore k, and best weights is having the distance on which it is taking the decision. Moving ahead, now the
Is
time has
your
come where
value
we'll
different from our value? Because I am getting K best value as 5.
yes, 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 yes. So it okay. I'll do it again. If I run it, the grid search CV will okay. It is giving me 3. Initially, it will give me 4. Let's walk through the whole code and then we'll rerun it again. The value keeps changing. So basically, it depends on the randomness that your value is selecting. So it keeps changing. So
You know that.
best KNN.
Yeah, just a minute. Uh,
Yeah,
Anjana, you would have noticed that the test and valid train data was split earlier, right? There is a randomness there. Typically, to ensure we get all the same results, you set a constant random seed. There is a
yeah.
random
So we
seed that
can
you have to set in the program. Then everybody would get the same result. Otherwise, you will everybody can get a different, because the way this 80% data gets picked up, that can play up
yeah,
in the final outcome little bit. There's a very
yeah.
small data set. If the data set becomes big, I don't think that will be so much relevant, that thing. Yeah.
Yeah. So as Sir said, we will add random state is equal to 1. If we put this, the data that my train test will spit will be based on random state 1. So now the data will remain same throughout. So if I run this
Anybody use it, yeah,
again,
anybody does
yeah,
it, it
yeah,
will get the same result. Yeah.
same result. So again, I'm getting value k value as 3. Then I'll train my final model, which is the best underscore knn. I will again call k neighbors classifier, and I will work around with the parameters that have been passed, which is n neighbors, which will use best k, which will have 3 in my case. Weights will be best weights, which will be again uniform, that is changed. So I'll pass both the parameters, and again we will fit the algorithm to learn. The learning of algorithm is done by dot fit, and again, as I said, only the training data will be passed. The moment we pass this, my algorithm is now trained. So if you see over here, it again gives me a clarity that n neighbors is used as 3. The moment the k value changes, your algorithm will also change the n neighbors over here. So once my model is built, I now make sure that my model is giving some results. So we'll make predictions on test. So since my model is now trained on X train and Y train, X test is unseen. So I try to provide X test with the model that I have trained, which is best underscore KNN. So Y pred best dot underscore knn dot predict, and this will predict on X test, which is unseen till now. The moment I run this, it will show. And if you want to see the results, we just print ypred. It will show you 0 1. So these are the category results that it is showing on the X test. To validate this, we again use matrix, which comes under sklearn. We will try to import classification report. So basically classification report
Yeah.
tries to give,
Sorry,
yes sir,
Madhav, just sorry interrupting your thoughts. Can you
yeah,
do y underscore pred comma y underscore test, both of them?
okay, yeah,
So
sure.
yeah, everybody can follow you then. Yeah. And, yeah, there itself, I think on line number 24. If you do that
Okay,
comma
so
comma
yeah,
y.
I'll print it like this so it will be more clear.
Yeah. Yep. Thanks.
I'll print. So this will have a gap in between. Yeah. So you can see the values
Yep.
over here. So if you can, this is the Y test that is not even shown to the data. I have passed X test. So you can see the values are, the model has learned really well. So the same thing when I try to pass it, we now once the model is learned, we try to use it, seeing the classification report. So classification report will give you one in one place everything. You will get accuracy, precision, recall of all the individual classes or the category, and confusion matrix, which we just saw, true positives, true negative, false positive, false negative. So I'll try to print using confusion matrix, and I'll pass the parameter the same, both Y test and Y pred, which is printed over here. Over here as two parameters. The moment I run, you can see that it has made. So yeah, over here, since the data is less, it has made
And this
100%
matrix,
accurate.
this is dependent on what we chose up, right? Or
Yes,
your
yes.
k-mean?
No. It
No?
depends on k-mean also, but it depends on learning, how we are trying to split the data over here based on this
Yeah.
and the k value both. It keeps changing.
Yeah. If you want to read this particular matrix, the way there are three classes, right? In this
Yeah,
data, there are three classes. So X represents what is on the rows. It represents, let's say, what is predicted. How much? Which, let's say, row one was about a species one, and then column one would have said that okay, species one. How many of the species one, which was actually species one, was predicted as species one? And how many of
correct.
them was predicted, though they were species one, but was predicted as species two or species three? So anything that is going away from the diagonal is in error. Okay, and
Over
everything on the
here.
diagonal is actually predicted and actual are same. That's how you have to read
Yeah,
it. And because if there is a number that is away from the diagonal, that causes the inaccuracies. This thing looks like 100% accurate. I think I will
yeah.
get in the next cell, it will get us 100%. Yeah.
Yeah, the reason of this getting 100% is I have trained my model multiple times, because I trained first with test, the splitting was run over here, and I have run my k-means twice. That's the reason my model has run twice. So there can be chances of overfitting. So initially when I ran it, it gave me the test accuracy gave me 0.97, which is 97% accuracy. But the moment I'll run this cell now to get the accuracy, I'll get it 1, which is 100%. So accuracy will be called with accuracy underscore score. I'll again pass the same parameter which was passed in confusion matrix, Y test and Y pred, and then I'll print it based on two float points. So the moment I run it, it's 1. So the test accuracy over here comes as 1. We make sure that we don't run any of the cell multiple times, because again it gets overfitted over it, because my model is learning twice the same data. So in that case, it can come. To make sure, we will again try to run it. Uh, just a second. I'll again run all cells so that,
We are
okay,
very
again it
close
has
to
taken
the
3.
time.
Yeah.
Yeah. In the meantime, any questions anyone has?
There is
Yeah.
one question, if we can use KNN for image
No,
processing. No.
no,
And
no.
is the confusion matrix 2 into 2 only?
It depends on the classification. We can increase it, but ideally, to understand it in from a basic point of view, it's 2 by 2, which is very easy to understand for us.
But
If
it
your
depends.
if
In this
in our case, yeah, in
it
this
is three.
case, we have
Yeah.
3, so it has segregated 3 by 3.
Also, there is someone who has asked if you can plot these points and KNN.
Plotting KNN.
Yeah, it could be a bar chart. If you look at,
Yeah,
if you can visualize with me, the bar chart, they can be, it doesn't make much sense to me, but I'm just
yeah,
trying to, if you want to experiment, this is all about creativity, right? So
Two axes and there is K mean. So perhaps you can
so,
plot.
so every row you can plot as a group of bars across three categories. So the bar which is one of the bars should be high and every bar is of different color. That way you can visualize how much the bars are taller than the side lobes. So let's say there would be 1, 2, 3 categories plotted 3 times. So in the first plot, in the first group of bars, let's say one bar is going very high and the others are not showing up if it is 100%. In the second group of bars, second is going very high, others are not showing up, and third. I'm just trying to align with what you're saying, but it is not making much sense to me
Yeah.
right
So
now.
I would add on this, since we have three outcomes, plotting won't make good sense because again, for us, identifying one category is more important at the last. Say, suppose I put a new input out of three, where does it align in category 0, in category 1 or category 2? So plotting won't make sense. Again, if this would have been a regression problem, plotting would have worked in that case.
As a question, how do you compute sensitivity in such cases?
Sensitivity is recall. So as you say, my classification report will generate the sensitivity automatically, and it's by default. So for an instance, I'll try to print it over here only. I need to pass the same for my classification, and here you go. Just a second. Classification. Yeah. By Fred. Yeah. So if you see, your recall scores are over here. Since we have our model is not making any error, we have 1 score on the recall. We have F1 score. The accuracy that we are generating is 1. So basically, they have taken 30 points in 20%, and based on that, it has made.
There's one question, KNN versus SPM, which is better?
Again, it depends on the output or the use case that you're using. As I said, if you want your use case is more towards finding similarities between your category or regression problem, KNN will work more good on it. If you want to work on linearity and non-linearity, in that case, SVM will play a vital role.
Also SVM is a unsupervised model. It's very intensive. It's very mathematical driven. Okay, it's a very mathematical thing. It's pretty complex. It has higher accuracy but low viability, I would say, in the real life world, and depends on how many lines you are trying to do. So yes, SVM is good to learn and theoretically, but I don't think many people use it. KNN is stands in a very different class. It's a supervised model. So many times we confuse between KNN and K-means, but KNN and SVM operate in the similar domain, but yeah, but different purpose altogether. Yeah, I hope that it's not a answer in yes or no, but one is very complex and sophisticated. KNN is very easy and serves many simple scenarios, life scenarios. Yeah. There is one question, one comment that Ms. Ankita Singh has posted. Can you take a session on Tableau? I'll give the feedback. Madhav, you probably have to take that feedback. If in
Sure,
the
sure.
10
I'll
series
take it.
session, if
Yeah.
this can be, I think it would have some value there in the 10 series, because many times people want to see all this data in a standard
Visualization format.
But people will
visualization.
need Tableau for that, right?
Yeah, they
Yeah.
would need Tableau, or they might be Power BI. So if you learn one, another will be an easy transition. I don't know what Madhav would have. Their team
So
probably.
basically, if you install Tableau, the software itself gives you 15 days to use it without any license. And if you're a student, and if you have any email ID that is tagged with your college with edu.com, you get 1 year free license from Tableau. So you can enroll, you can get the 16-digit code of your license by just applying, giving your ID card as a proof, or just directly signing up with your educational email ID which your college has given. So from there you get 1 year free of Tableau license. Yeah. So that brings end to the coding session. So based on that, um, let's try to have a view that what would be the upcoming session. So basically, next session that we will be conducting would be on logistic regression. So say logistic regression giving its own introduction. So hello, I'm logistic regression, a versatile and widely used classification algorithm in the realm of machine learning. My purpose is to help solve binary and multi-class classification tasks, enabling you to make decisions based on input features. So it uses sigmoidal function gracefully and transforms raw predictions into probabilities between the ratio 0 and 1, not above 1, not below 0, providing valuable insights. So to know more, stay tuned with us. Happy learning.
Thank you for doing that, Madhav. I think this is also a good session for those who missed the earlier regression part, because except for using log values, I think the whole concept of regression stays there, right?
Right, yeah.
Okay, great. Thank you so much for finishing it before time. Normally, we are almost always, we exceed the time. And I can just request all of you to come on screen so that we can take a picture. A lot of people are putting, if this will be, there will be slides we will share or something. So there will be no slides which will be shared. We'll put the recording of this session on YouTube, and I think that should be good enough. So thank you, everybody. I'm just removing the spotlight from Madhav so that all of us can come on screen. We're just going to take a picture. Smile. Thank you. Thank you. Thank you, Aishwarya. Thank you, Madhav. Thanks,
Thank you
Vineet.
for this opportunity. Thanks all. Thanks, Madhav. Thanks, Vineet.
Thank you. Bye-bye.
Thank you, everyone.